Questions, problems you'd like to see worked off of that page before you ask? I think I'm going to do these two problems. So this is problem 29. I did A and D. I put A and D on here. We're going to work them out just so I make sure everybody understands how to do them and how you should do them. Try to give a little explanation. They tell us in problem 29 that S is between R and T. When we go to take a test or a quiz, which we have coming up pretty soon, if I put this problem on there, ignore that stray mark, and they tell us S is between R and T, you do that and you label it, I give you a point. All right? So when we do a problem like this, and I can't remember what they ask us to find, so you might have to help me. When we do a problem like this, it might be worth 5 or 6 points. All right? It might be worth quite a few points. You draw it. They tell us RS is 2x plus 10, so I label that 2x plus 10. Again, ignore that crazy mark going up through there. ST is x minus 4, so I label that. And then RT, which is the whole thing, they tell us this time is 21. You have that on your paper, that drawing with all of it labeled, you get a point. Second point would come from setting up the equation. The segment addition postulate said this segment plus this segment should equal the whole thing. So you just come over here and you write 2x plus 10, that's the first segment, plus the second segment, which is x minus 4, ignore that stray mark, should equal the whole thing, which is 21. That's a 4.
That's the one I had problems with at home.
You get that down, that's a second point. 1 point for here, 1 point for this. All right? Next thing we're going to do is we're going to solve this. First thing I do is collect like terms. 2x and x give me 3x, 10, and a negative 4.
6.
Minus 6 on both sides. Good. 15 equals 3x. Still, these canceled out. Divide by 3.
X equals 5.
X equals 5. You get x equals 5, and that's correct. A third point. Then I think maybe they ask you to find all the segments or something. Is that what they ask us on this one?
Yeah.
So we want to find RS. RS, to find RS, all we do is we take this 2x plus 10, and we take out x, and we plug in 5 in its place. What's 2 times 5? Plus 10? So segment RS has a length of 20. We already know segment RT, so I'm not going to give you a point for finding RT because they told us that one, right? But we still got to find ST. Plug in right there. We said x was 5. What's 5 minus 4? 1 point, 2 points, 3 points for the picture, 4 points, 5 points. 5 total points that question would be worth. But you got to show me all that.
I can't help but notice that the segment with the smaller number was the bigger segment.
Right. So when I draw this picture, is my picture drawn to scale? No, because I can't draw the picture to scale unless I know how long each segment is, right? And I don't know how long each segment is till I go through and draw the picture and solve for all of them. So when we're drawing these, don't go by what you draw. I guarantee at some point throughout the year I'll tell you to draw a triangle. And you'll draw a triangle, and it'll either be that triangle or it'll be this triangle. It'll be one of those two triangles. Did I tell you to draw a right triangle? No. Did I tell you to draw an equilateral triangle?
No, you said
No.
draw.
I said draw a triangle. So when I do that and Dawson says, oh, I know all 3 sides are the same length because it's equilateral. I didn't tell him to draw an equilateral triangle. So you gotta, don't go by the picture, go by the information that you know for this whole class, all the way through the year. Does that make sense? Did I talk last time about these marks?
No.
When in a picture, when you see something that has tick marks on it. Let's say these two segments have a tick mark like that on each one. That tells us that those two segments are equal or the same length. Right? So up here in this triangle, what's that tell us about those three segments?
Same length.
So all three the same length. Anytime you see that, those are congruent segments then when they have those kind of tick marks on it. Here in a few days, we'll get to angles and we'll mark the angles if they happen to be the same. But anytime you see that, maybe next time they'll put two tick marks on each one. Still tells you the same thing. Next one, I'm going to run through this real quick. Did that help a little bit? We still know that S is between R and T. So S is here, R and T. Segment RS is 4x minus 9. Segment ST is 19. The whole thing, segment RT, goes from here to here, is 8x minus 14. And I know some of you are thinking in your head right now, well, I don't need to write all that out. I could just set up the equation and go. I don't need to draw that picture. I had a young lady in intervention yesterday doing this part D right here, this exact one. And I solved it and she solved it. And she figured out that she had the wrong answer because she'd set it up wrong. Because she didn't draw the picture. She just set it up the way she thought it was supposed to be. So you've got to make sure that you're setting up things correctly. So on this, that segment, 4x minus 9 plus 19 should equal the entire segment, 8x minus 14. Now I'm going to solve this real quick. 4x plus 10 equals 8x minus 14. Subtract 4x on both sides. Get all the x's on one side. One thing I will say right here. Always get all the x's on one side before you start messing with the numbers. Because it's not that it's wrong if you do it the other way. But I've seen many students over my years of teaching, when they do the numbers first, then the variables, they get confused for whatever reason. I've never been able to figure out why, but they get confused. These cancel, you're left with 10 equals 4x minus 14. Add 14 to both sides. You end up with 4x equals 24. Divide both sides by 4, you end up with x equals 6. So you got a point here, point for the equation, point for finding x. We take that x, we already know this one, to find the RS, the length. Plug 6 back in. 6 times 4 is 24, minus 9 is 15. Find RT. 8 times 6 is 48. 48 minus 14 is 34. 2 more points there. Other questions off of that page that you'd like to see work?
27.
27? Is that what you said, Dawson, was 27?
I'm just seeing if I got them right.
That's what we do this for. 27. Using structure, determine whether the statements are true or false. Explain your reasoning. Let me erase this, pointer options, erase all. Forget that this stuff's over here. Try to draw this picture. Ignore that red line. It's going to be hard to do since I'm drawing in red, isn't it? We got that. We got this. We got this over here. We got something that runs like this. A, B, C, D, E, F, and H. Ignore that stray mark. Part A. We're just telling, determine whether a statement's true or false. We're telling true or false. B is between A and C. B between A and C? Yeah. Remember, to be between, they have to all be collinear to each other. All right? They all have to be collinear. C is between B and E. C is between B and E. False. Letter C. D is between A and H. Is that between A and H? And D, E is between C and F. False. Because what's true about this? Is that a line? No. It's got a little crook in it, right? Other questions? Yes, Alyssa.
42.
42? (42) 5x plus 7 equals 9x minus 17. We just want to solve that, right? First thing you do is subtract 5x on both sides. 7 equals 4x minus 17. Add 17 on both sides. You end up with 4x equals 24. Divide by 4. X equals 6. Is that right? Now I had somebody yesterday ask me, let's just look at 43 because maybe that was the one. 43, they give us this, 3 plus y divided by 2 equals 6. How do you start that problem?
Put the 6 over 1 and cross
You could do it that way and that would be fine. Make them into a proportion, cross multiply. We'll do some problems later on this year that I'll tell you to do it that way every single time. When you multiply, when you cross multiply here and you take 1 times that, what's it give you? Just that, right? So we end up with 3 plus y on one side. On the other side, what do we get? 12, right? Now, I wouldn't actually do this problem that way, but if you do it that way, that's fine. Don't change it because it's not going to make any difference which way you do it. Whenever I see this, I always remember that that bar means what operation? Division. So I know, hey, if I'm dividing everything by 2, to get rid of that, then I multiply everything by 2. If I multiply this side by 2, what do I got to do to the other side? Multiply it by 2. When I multiply 6 by 2, what do I end up with? 12. On this side, what happens with the 2's? Cancel out, and you're left with the same thing. Subtract 3 on both sides. This is the problem I thought it was. You end up with y equals 9. Back to my original point. Somebody said that one of their answers was coming out to be a decimal. Is it all right for an answer to come out to be a decimal or a fraction?
In this class, yes.
Yeah. Don't think you're not in 5th grade anymore, all right, where everything came out all nice and even. You're going to have decimals and fractions throughout the year.
What grade do you
Might be. Problem 40. Let's just look at problem 40 real quick. What's that say? 25 plus 9? Is that what it says?
I don't know.
I think that's what it says. Does everybody know what this symbol is? Square root. Now, I had my son come home. He was in 7th grade. His first assignment was he had a problem that looked like that. Anybody know what that means? The cubed root. Could be the cube, could be the 4th root, 5th root, whatever number's out there. You're used to seeing nothing out there, and that just tells us that there's actually a 2 out there, and we just take it for granted that it's there, and it's really not. Square root. Square root of 34. What does the square root of 34, what's that asking us to find?
What 2 numbers go evenly into that?
All right, so what number, some number, times itself that gives you 34 is what you're looking for.
It's gonna be a decimal.
All right, and 34 is not a perfect square number, and we'll talk about perfect square numbers, and we'll get a list. When I was in school here, I wasn't the world's greatest student, and Mrs. Evans said, you need to get a calculator for this class, and I gave her some garbage story about we were too poor to get a calculator, and so now you give me this story because I won't believe it because I tried to use it when I was here. And it's not true, I don't buy that, because there ain't none of you as poor as I was when I was going to school here, and I had plenty of money. I could have bought a calculator, I just didn't feel like buying one. All right, so when I had to do square roots, I never had a calculator, so I had to do them out longhand. You don't want to know how to do a square root longhand. All right? And Mrs. Evans didn't have a problem. She knew I was being a smart aleck and just not getting a calculator. She showed me how to do it longhand. And as long as I wouldn't be a smart aleck, she's going to let me do all that extra work. When you do something like this, for now, we're not even worried about it. Could you give me an estimate?
5.67.
He must have used a calculator.
No, I did it.
I bet he did.
I don't have a calculator.
So we look at that. How could you get an estimate?
Do 5 and 6.
All right, we know that the square root of 25 is 5. The square root of 36 is 6. It's going to fall somewhere in there. And I take that back. Dawson didn't use the calculator because he was pretty far off. Which one of these is it closer to, 5 or 6? Closer to 6, but it's still going to be 5 point something, right? It's quite a bit closer to 6 because it's 9 away from 25 and it's only 2 away from there. So my guess is it's probably about 5.8 something. 5.83. So that's what I had to do when I was here. Now the other thing that we're going to do that you should have learned in algebra last year. When you have square root of 34, we can try to break it down and make it a simpler radical and just leave it in radical form. And we're going to do that a lot here. This won't break down. Give me two numbers that multiplied together will give you 34. Don't have to be the same number, just any two numbers multiplied together. 2 will, right? 2 times what?
1, no.
17? Everybody agree with that? Now the bad thing with this is 2 a perfect square number? 17 a perfect square number? So what I'm going to tell you as the year goes along, if you see this answer, leave it that way. That's the best answer because it's an exact answer. All right? What if we had this? Square root of 50. That's not a perfect square number, but it will break down. What's a perfect square number that will divide evenly into 50? 25. 25 times what?
5.
What is the square root of 25? So that comes out of the radical. The 2 stays under the radical. That's the best answer. 5 times the square root of 2. Did you do any of that last year in algebra?
I did it
We
a
didn't
couple
really
times.
do it. We didn't really do the large numbers. We did square roots, that's all.
We went that, we already did that. I'm going back over rulers again. All right, notes for the day, formulas. Yeah, we sort of did. I'll go back over some of it. Like some of it's right here on this. I promise you I put something. Well, we got 30 minutes. Yeah, we were going to go back over some of it. Well, it'll be on here. Scream.
Yeah, like that. I need to like.
Today, what we're going to cover, formulas. Put that title on there, formulas. I'm going to switch the screen here in a second. We will go back over some of the notes that we missed last time. They'll be on here.
Today's
Stuff like the congruency. Today's the 30th.
No, today can be the 30th.
Yeah.
Today is the 30th.
Monday was the 28th.
Today's the 30th. Today's the 30th. Today is the
Tuesday
30th.
was the 29th.
Still the 31st.
Look at tomorrow is the water. It's hot.
This, we talked about this last time, postulates, axioms. Actually, if you wrote this down last time, I think maybe I've forgotten here. Corollaries also go with postulates and axioms.
But you said you won't use axiom.
We won't use axiom, we won't use corollaries. The word I want for all those is just postulate. All of them, all they mean is a rule that we take for granted is true. All right, just something we know it's true. It doesn't matter why it's true, we just know it's true. A theorem. Theorem's a rule that has to be proven true. So when we take a definition quiz or something next week, which we will, and I put postulate and theorem on there, when I put postulate on there, all you need to write a rule that we take for granted is true. Theorem, something that we have to prove true. Coordinate system, we talked about that last time, right? We're not going to go back over that. Everybody remember that? What's that point right there called? Origin. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Construction. This might have been the stuff that some of it we didn't get to last time. I just want you to know what a construction is. You might write down the other stuff. I don't even care if you write down construction. A construction is just when you make something. We're going to do some constructions in here. We'll end up taking a ruler, protractor, compass, and drawing angles and triangles and special triangles and all kinds of stuff maybe. So that's all a construction is. Congruent. This is the symbol for congruent. Don't get it confused with this symbol. Does anybody remember what that symbol means?
Equal to,
About, approximately. All right? Don't get the two confused. Congruent's just a symbol that we use when we're naming like segments and angles and triangles and stuff. Because we don't want to use equals. When you're using words and letters and symbols, you don't want to use equals. You use equals when you're using numbers and variables. So you use equals for algebra stuff, you use congruent for the geometry stuff. When you have congruent segments, not sure what this is right here, it looks like got some stray marks on there. That's supposed to say, oh, I know what it is. See my segment symbols? My computer doesn't like me. So one of my segment symbols is here and one of them's there. It got scattered somehow. That's supposed to say segment DF is congruent to segment HP. That's how that's read. Segment DF is congruent to HP. Last time we also talked, if you just want to tell the length of a segment, then you just write DF without the segment symbol equals 7 or whatever. We use the equal sign instead of a congruent when we start putting numbers and stuff in there. Congruent goes with the letters and symbols. Equals goes with numbers and variables.
on the side of the measurement, like if we measured in inches or centimeters, do you want us to put that beside the number as well?
Oh, you mean the units?
Yeah.
Yeah. Yeah, if they give you units and put it on there, a lot of times in this book they won't give you units. They'll just, that's somebody being lazy, just give you numbers. We started to talk about this, I think last time, maybe didn't get completely to it. If we have, and we're going to do more with it this time, we're actually going to be able to do all this. If we have that horizontal segment, how can we find the length of it? Count. Just count the squares, count the spaces. All right? If we have this vertical segment, how can we find the length of it? Count the squares. If I have this segment, segment DA, can I do that same thing? It doesn't work, does it? It doesn't work to count across, because if I start counting and I say that that right to there is 1, are those going to be the same as I go across through there? So on diagonal segments, it doesn't work. So what you might want to write down is for vertical and horizontal segments, all you have to do is just count.
Why don't you, for diagonal ones, just count up and over?
Doesn't work. That would be the slope. Now, we're going to talk about diagonal segments here in a second. That's why I didn't write them. Vertical and horizontal, you just count to find the length. Okay, so if we graph 2 points, graph this point, and we graph that point, we say, oh, all we got to do is count. 1, 2, 3, 4. 4 units long. But if we graph this point, and we graph this point, you can't just count. And that's what we're going to talk about next, is how to find the length of that segment. I guess not next. Be right after this. Midpoint of a segment. When I said something about a definitions test or quiz coming up, I think midpoint might be on there.
Yeah.
Yeah. We use midpoints over and over and over and over again throughout the year. Stupid things. You see this segment symbol that's floating here in the middle of nowhere? It's supposed to be above that FG right there. I have to fix my PowerPoint. So that one that's floating in the middle of nowhere, don't put it on your paper. It's not anything. Yeah, Jacob, I magically put it back over there. Midpoint. Midpoint of a segment is the point that divides the segment into 2 congruent segments. Don't tell me middle. Don't tell me between, any of those words, because you get them all confused. When we start talking about midpoint, you got to know it splits the segment up into 2 exactly equal segments. All right, 2 congruent segments. We just got done talking about these tick marks. What's that tell me about segment FM and segment MG?
They're all equal.
Stupid thing. So I could write this: segment FM is congruent to segment MG. If I know M is a midpoint. If M is a midpoint, then those 2 segments have to be congruent. We could put 1 tick mark on each one. A lot of times I'll put 2 tick marks on them just because that way I make sure you see it. There's all kinds of stuff you could put on it. It doesn't have to be tick marks like that. Other ways that we could show 2 segments are congruent, maybe I put a V and a V. As long as they're marked the same, that tells us those are the same, they're congruent to each other. So if I told you segment FM was 12 centimeters long, what else do you know? MG is 12 centimeters long. Give me something else you know.
FG is 24.
FG is 24. Very good. We also know the whole length. Next one, a segment bisector. Does anybody know what the word bisect means? What do you do in biology class? You don't bisect, you what? Dissect. That means you take something into many parts. What's the prefix bi tell you?
Putting them together.
2. You're taking something into 2 parts. So a segment bisector splits a segment into 2 congruent parts. The segment bisector here, we could name line BF. It bisects that segment because it splits it into 2 congruent parts. What do we call point W? We just did it on the last slide. It's a midpoint, all right? You could, segment bisector could be anything. Could be a segment, could be a line, could be a ray, as long as it splits the segment into two congruent segments.
So if you have two lines intersecting with each other, does there have to be a dot there? Or like a?
Where they intersect?
Yeah.
Yeah. They won't always show it, but it's there. Now, does this line bisect this line? Why not? Can a line be bisected?
No.
Can a ray be bisected?
No.
No, what's the only thing that, for now, that can be bisected? A segment, because we can actually measure it. You can't bisect lines, you can't bisect rays. Or planes. Two formulas. I'll give you a minute to write this formula. Anytime you're on a coordinate system, so you see a problem and it looks like this. You can about bet you're going to be using one of these two formulas to find your answer. Make sure when you write these down, you write your formulas down correctly. A couple years ago, I had a young lady, a very smart young lady, wrote formulas down in her notes. And when I was checking quizzes and tests and stuff, she was missing every distance problem formula. I thought, man, she doesn't miss anything else, but she's missed every single one of those. I couldn't figure out why. And then so I went and talked to her and asked her, and I said, well, get your notes out so we can look at the distance formula. She had it written down wrong, and she was using the wrong formula. So make sure you write it down correctly. And for those young men that I have in here that maybe your writing's not the greatest, make sure you can read it. Dawson's up here saying he doesn't have a calculator. How many of you is going to be able to do that formula right there if you don't get a calculator here in the next day or so? You ain't going to be able to do it, Dawson. I'm sorry. It was a rhetorical question. I already knew the answer. None of you. Get a calculator, even if it's borrowing one off somebody. Midpoint formula. Midpoint formula is very easy. Don't make it harder than it is. All right? That should be the easiest formula that we do all year long. With the midpoint formula, you're on a graph. Both these are going to be used when you're on a coordinate system. You have some point like 5, 2, over 5, up 2, negative 7, 3. And what you're trying to find is the point that's right directly or splits that segment into two equal parts, two equal segments. So we're trying to find the coordinates of some point in that area right there. All right? Oh, sorry. Thank you. So it should be up there and our midpoint's going to be there. I should have just did this and it made it easier instead of trying to change my graph. All you're going to do with the midpoint formula, these little subscripts mean absolutely nothing. They just tell you that you have two different x's. What are my x's and my 2 points that I have right here? 5 and negative 7. So you're going to put in 5 right there plus negative 7. What's my 2 y's from my 2 points?
2 and 3.
So I put in 2 here, 3 here. It doesn't matter if the 2 comes first or the 3 comes first. Makes no difference. When you did slope last year, order made a difference, right? If you mixed around the order, it messed up your slope. With these two formulas, the order makes no difference whatsoever. What's 5 minus 7?
-2.
-2. What's 2 plus 3?
5.
And then we do the math. What's -2 divided by 2? -1. 5 divided by 2? 2.5. Guess where that point right there is going to be at?
-1.
-1, 2.5. So my graph is not very good, but should be somewhere around in there. All you're doing, you're adding the x's together, dividing by 2, adding the y's together, dividing by 2, to find the midpoint. Should be easy. Distance formula a little harder, it looks a little more difficult. Again, these subscripts don't mean anything. The 2 and the 1, they just tell you have 2 different x's, 2 different y's. These numbers do mean something. Tell you that you have to square your answer when you get it. What number would I put in here for this x? For my 2 points up here?
Oh,
5. How about this x?
-7.
-7. You got to be careful when you're doing this.
Positive.
What happens when you're
Plus.
subtracting a negative?
It makes a negative a positive.
Changes it to a positive. Over here, what y am I going to put in here?
2 and 3.
Then I do the math. And you got to do this step by step. If you have a calculator that prints across the screen, you might be able to punch it all into the calculator and let it do it all. Be careful though. If you're getting the wrong answer doing that, then you're plugging it in there wrong somehow. You might be missing a parenthesis or something and it gets a little confusing. So when I do this, even though I'm a math teacher and I've been doing math for a long, long time, longer than you guys have been alive, I don't punch all this into the calculator all at one time. I do some of it in my head, then I punch the last part into the calculator. The parts I do in my head, I do this. 5 plus 7 is what? 12. And you're going to square that. 2 minus 3 is
1.
-1, and you're going to square that. What is 12 squared?
44. No, 144.
144 plus, what's -1 squared? +1, and then I add those two. That's 145, and the only thing I do in the calculator, because I can't take a square root in my head, is I grab my calculator and I figure out what the square root of 145 is. Is 145 a perfect square number?
No.
No. And I'm going to tell you, that won't break down any. You could just leave your answer that way. So I sort of lied to Dawson, because could he do this problem without a calculator? Yeah, because that won't break down any, and that could be his answer. Unless they ask you to change it to a decimal form. If they want a decimal answer, then you got to round it off and give the decimal answer.
Which it would be 12 point something.
It's like 12 point, probably 12 point, not even 1, probably 12.0. So midpoint formula, distance formula. How are you going to know if in a problem if you got to use the midpoint formula? What are they going to be asking you for? Find the midpoint. That's key. Use your common sense. They say find a midpoint, try using the midpoint formula. They want you to find the length of a segment. Which formula are you probably going to be using? Common sense stuff. What do we got, Doc? Oh, the clock's right now. 15 minutes. Open up your books. This is going to be part of your homework. We're going to add some of this to your homework. We're going to work it together up here. Just get out a piece of paper, open up your book. Page 24. Page 24. I don't know if I put any of these on here or not. Nope. Number 1, what we'll do with this, I'll put your homework assignment up here in a second. It's not this, but this will be added, or this will be part of it. So when I put up the actual assignment, whatever we don't get done out of this stuff will just be part of that homework assignment. Does that make sense? Number 1, If a point, ray, line segment, or plane intersects a segment at its midpoint, then what does it do to the segment? It's that B word that we talked about. It bisects it. If it goes through the midpoint of that segment, then it bisects it. Number 2, complete the sentence. To find the length of segment AB with endpoints, whatever they say there, A and B, you can use the blank. What are we going to use? The distance formula. Distance formula. Use distance formula to find the length. Use a midpoint formula if you want to find the midpoint. Number 3, they want us to find the length of segment RS. How long is segment RM in that picture? 17. They tell us that, right? How long is segment MS? 17. They want us to find RS, which happens to be the whole thing this time. How would we do that?
34.
Add them together. 34. Gosh, this stuff's so easy. Next one, same idea, right? They just moved the 9 over to the other side thinking that they were going to confuse somebody. How long is segment RM in that picture?
Well, it's 9.
9. How long is segment RS? I knew I'd get somebody. 18. Oops. Number 5. Just tell me RS. 44. Everybody agree with that?
Yeah.
Just add 22 and 22. Number 6. 24. Oh, number 7 is a little harder. Identify the segment bisector, then find the length of segment JM. So we have this picture. That's J, that's M, and that's point K. This is 8x, and this is 7x plus 5. And they put these little tick marks on here, and that tells us what's true about those two segments. They're saying they're congruent. So what equation can I, first, if these two segments are the same, then what's the segment bisector in this case? Point M. Point M, so that's part of our answer. Then we're going to set up an equation. What equation are we going to set up? Unlike the problems we did at start of class, are we going to say this plus this equals the whole thing? We don't have to do that this time. What do we know about these two segments? They're equal the same, or they're equal to each other. So what equation can I set up? And that's one of the problems that a lot of you are going to find in this class is you got to know what equation to set up. Sometimes you're going to say this plus this equals the whole thing. Other times you're going to say this equals that. All right? And those people who have trouble, what they'll do is they'll always say this equals that because it's easier. And that doesn't help because that's not always the case. What do I do here to solve this? Minus 7x.
What X? So just X.
X equals what? 5. What'd they ask us find? JM? So we want to find the length of segment JM. How are we going to do that if we know X is 5? Plug it in. Now, if I plug it in, I probably would not plug it in right there. I'd probably plug it in right there. Because 8 times 5 is what? 40. I know that in my head, and the reason I would plug it in over there, because what do I know about these two segments? They're the same. So if that one's 40, that one has to be 40. If you can make your work shorter somehow, do it. If you can make it easier, do it. Don't make it harder than it has to be. What number was that? 7?
Yeah.
8. Without me drawing the picture, just tell me the equation to set up on 8. Well, first tell me the bisector. Line L. Everybody agree with that? What's another thing you could have said bisects in that picture? Point M again, right? Tell me the equation you could set up.
3x plus 15. And then 8x plus 15.
Forgot something in there. Equals 8x what?
Plus 25.
I'm gonna solve this just real quick. 5x equals 40, x equals 8. They ask us to find, what, JM again?
Yeah.
And that was 3x plus 15. 3 times 8 is 24. 24 plus 15 is 39, is that right?
Yeah.
Those are your two answers.
Mr. Emerson, how do you get 40?
How'd I get? Ah, I was wrong, wasn't I? Jeez, you guys gotta stay up on me. That's like 3 mistakes I've made today. No, it's not.
Oh, you're right.
Negative 10, so what's x?
2.
Negative 2. That messes this up. Dang, I can't believe 3 mistakes in one day. What's 3 times negative 2?
Negative 6.
Negative 6 plus 15,
Is 9.
9. What can't happen there? Can your x be a negative? Yeah.
It can be
But the
anything.
length of a segment can't be a negative. So once you plug back in, even though x came out to be negative, did our segment come out to be negative? I'm gonna have to start watching what I'm doing. Can't make any more mistakes. Identify the segment bisector and find xy. Same idea, right?
Yeah.
What's the bisector this time?
And
Point M, I'd accept that. Give me something different.
line xy.
That's the thing that's being bisected.
Line.
How about ray MN? That could be your bisector.
Oh, yeah.
Set up the equation there. Anybody set up the equation on their paper already? Let's see, 3x plus 1 equals 8x minus 24. Make sure I don't make a mistake here, Connor. That's 5x, that's 25, x equals 5. Does that seem right? Once we know x equals 5, now what do they want us to do? Find
xy.
xy. And be careful on this one, because now instead of finding just part of it, you're actually finding the
Whole.
whole thing. So we plug in, what's 3 times 5?
15.
15 plus 1 is 16. If this part's 16, how long's the other part?
16.
So how long's the whole
32.
thing? So that's your second part of your answer. Ray MN bisects it, and the whole thing is 32. Peyton, did I lose you trying to do all that in my head there?
Yeah, I got lost.
Alright. So I won't do any more in my head. Number 10. What's the bisector in this case? Line what? Be careful. Line N, right? Because it's a little letter. Or you could say point M would work. On this one, we know those two segments, because that segment's being bisected, we know that they're congruent. So 5x plus,
8 equals 9x plus 12.
ignore all those stray marks. Don't know why they're doing that. Subtract 5x on both sides.
4x.
Now it's better, right, Connor? Because I'm actually showing you how to do it instead of spitting words at you.
Add 12 on the other side.
How about subtract 12?
Well, I'm saying add 12 on
Nah,
the other
that's not so.
side.
That's a negative 4 equals 4x. Divide by 4, what's x come out to be? The negative 1. Be careful there. Negative 1, don't forget about your negatives. They want us to find segment xy. So we plug in. We have 5x plus 8. In place of that x, I'm going to stick in a 1. What is 5 times 1?
5.
Oh, I'm sorry. Should be a negative 1 here. I'm telling you to be careful, and I forgot it. What's 5 times negative 1?
Negative
Plus 8
is
3. So half the segment's 3. What's the other half of the
6.
segment? So how long's the whole segment? So this is one answer, line M. That's the other answer they wanted. Copy the segment, construct that. We're going to skip 11. .15 through 30. On 15 through 30, just looking at 15 through 18. Says those are the endpoints of a segment, find the midpoint. What formula are you going to use on 15 through 18? Midpoint formula, right? Then on the next part, midpoint of M, endpoints, these are a little harder, see if you can figure them out. Then on 23 through 30, it says find the distance between the 2 points. What formula are you going to use? Distance formula. That's your assignment. Just add that stuff to what you wrote down there a second ago. Guarantee somebody will ask the 19 through 22. Those are the ones that everybody has trouble with. Actually, 19 through 21. Because I didn't put 22, I took it off, I don't know why. Oh, because it's got a fraction in it. Must have had somebody last year whining about fractions.
What was the last thing?
What last thing?
No, what was the other thing? It was like 15 to 30.
Yeah, that's right.
Oh, I just said 15 through 18, you're using the midpoint formula. 19 through 21, you're doing the midpoint formula. And then 23 to 30, you're using the distance formula.
Orange looked like accent and all this.
No, what we had on the other slide, we did up through like 15 there, and you're just adding this on to what we already done. Make sure calculators. So if Dawson says he can't find one, get a friend in. Dawson can
I don't have any friends.
Dawson
Everybody
can
hates me.
treat somebody nice for a day and just act like he's their friend, right? And maybe they'll loan him a calculator.
What was the laugh at? Hey, dude, come on, did you ever
Clean off my shoes.
Here, then, hold on.